Yes, welcome back, guys. So this will be the third part of the agent harness series, and I think this time the entire setup is a pretty good, right? So I'm in a different place right now. This is a temporary place though, and I guess the audio quality and the camera quality should be good now. Perfect. Let's get started without wasting any time. So what we see here is that in the last video where we left off is we built a persistence layer, right? So whatever the conversation we have with the agent, so that was not persistent, meaning that we didn't store it anywhere, and we just set up a quick simple SQLite database so that we can store those data over here, right? So we have like one conversation here and not here, sorry, here. So we have like 5 conversation and we're storing all the JSON data over here. That's what we built. So now when you start the server and then send out the session ID, it'll automatically remember all the context. That is perfect. Now there's one more problem now. The problem would be about how long can you have this conversation. So can I have this conversation throughout a week, throughout a month, throughout the year with the same session ID? That's the problem now. So let's see. First thing is we're using DeepSeek V4. Okay, DeepSeek V4 Flash. So let's check out what is the context window of this. So if I go to models.dev, okay, this is like a simple registry handled by um, some group of people. Okay, it's open source, by the way. You can also go and check out their GitHub. So you can get all the details of the models LLM throughout. Whatever the LLM is available, open source, closed source, any sort of LLM, you can get the details here. So you can go here and search for DeepSeek V4 Flash, and you will get it. So I'm going to click on this. Alright, so here we have some details. The first detail is it's from DeepSeek and it's an open weights model. So open weights model, the meaning of open weights model is that whatever the training data, or not training data also, whatever the weights they use to train the model, weights in a sense, the inputs that they used while doing the I think it's supervised training, supervised learning or training, I'm not sure about the term, but these weights are open so that you can actually go and see what are the input data they gave to the agent, like when in the training phase, what are the input data they gave to the base model, and what is the response it got and all those stuff. So it's pretty open. So, and you won't get this in GPT and Claude. Okay, they are all closed source. Okay, this is open, so you can go and check it out. And what we are looking right now is the important detail we want is this context. Okay, this context, this 1 million. So what does it say is that this particular DeepSeek V4 Flash that we're using, the maximum context it can remember at a particular time is 1 million tokens. So what exactly is a token? Let me show you. Tick token or tick tokenizer. Tick tokenizer. Tick token online, not TikTok online. Okay, tick tokenizer.app. This is the one. So let's do one thing. Okay, so we'll go back to our chat and we'll go to our project. I'm going to copy the question I'm sending. Hey, what is my name? So I'm going to copy this. Okay, I'm going to system prompt can be same thing. So system prompt is something that we given here, right? So LLM, you are a helpful assistant and your name is Cairo. So I'm going to copy this, paste it here, and then I'm going to go back and then I'm going to copy, hey, what is my name? So this is what we sent to the agent, sorry, LLM, right? So I'm going to send add a message. So sorry, not add message, remove this. So now look, just observe what's happening. So I think I cannot select DeepSeek here. Let me see, DeepSeek. Okay, we have DeepSeek R1. There's no data. Okay, let's select GPT itself. The concept is similar regardless of what model it is. So it shouldn't matter. It shouldn't matter. Okay. So this is what we sent. The system prompt was, hey, your helpful assistant, your name is Cairo, and the user is, hey, what is my name? This is what we sent. So here you go. This is what the LLM sees. Okay, this is what the LLM sees. So every single word. So if I hover on 2000 what is this? 2 lakh 264 here. It says I am start. Okay, and then you have 17,300, which is system. Okay, and then you have 2066 again. It is I am SEP. So what exactly are this? This is very important to understand. Okay, please do not skip this. It's very important for you to understand. So these are special tokens. Okay, these are special parameters added during the post-training phase. So you have the base training done for a model, that is the pre-training phase where you get all the internet data and then just feed it. In the post-training phase, you need to have certain meaning for the words. So you have like system. System is the system prompt. So you're telling the agent LLM that, hey, this system prompt is something that you need to remember every single time you process the transaction. So what we're saying is, hey, if this is like an HTML open tag and close tag. Okay, so if this shows up, I am start and I am SEP. So whatever that is inside it, treat this as a system prompt. So system, and this here, right? This will mark it as an important variable, and if that variable is equal to system, then whatever comes after that Okay, whatever comes after that will be considered as a system prompt. So you can see it says IM start and then system IM SCP and then IM end. Okay, so all these three will be combined to get a system prompt. I'm going to explain this again. IM start and IM end is something that will be like collectively your system prompt, and after you're saying system, you're stopping that by using IM sub. Think of this as a colon, system colon or system equals to this is your value. Okay, so that's what this says. Now the agent or the LLM who's reading this will go through this. Okay, that is this particular token. It will understand, okay, if we are starting something, and this 200264 will always be same for this, regardless of whatever you enter, it will always be same. Okay, and it will encounter system, then it will search for the next word, but the next word is the tag. Now it will understand, okay, so here I'm coming to an end, so whatever I read before, that is system, this is the variable. So what is system? It will have a meaning. Okay, if you encounter something called system, then you have to remember the context throughout the conversation. And what is the context? This is the context. And how does it know this is the context? Because we're ending it here. That's all. Okay, and then we're doing the same thing for IM start and its user. So now the agent will remember, okay, this is the input I'm getting from the user, and it say, hey, what's my name? And IM end. Okay, and then it says IM start assistant here because we added like assistant before it. That's the reason I think it got updated, but it shouldn't happen. Okay, but why I'm telling you guys is that because if you go here, you see 1 million, but you have to know what is this 1 million number, right? It's not 1 million text content. Okay, it's not like you enter what is this? Alright, you go here. It's not like you go here in your JavaScript console and then say like, hey, what's my name, and then do dot length. Okay, it's now you get 21. This is not the context length. Okay, this is not the 1 million. Like now you cannot do like, okay, 1 million minus 21, I have like so and so remaining. This is not the case. Is this 1 million? Yes. Okay, so 1 million tokens. So now this entire thing is 31 token. Okay, this is the whole context. I can make another deep dive video on this one also, but this is a very huge concept, and I would recommend, if you have patience and if you are open to learn, watch Karpati's video on this. It's called Building ChatGPT. It's 3 hours video, and you might have to revisit multiple times to understand things, but he explains this very beautifully. I can make it simple and explain this again. If you guys can comment it out, maybe I can do it in the next video, but yeah, let me know if you want it. Okay, and yeah, so now this is what it will show. So now you can do instead of 21 you would do 31. Okay, this 31 is combination of these two, and you might ask me, we have so many words here, why 31? So if I show you, if I hover on this thing, 30, 53, okay, if I hover on 53, what do you see? You see ARE with a space. So space and ARE is considered as this one token number. Okay, and similarly if I hover on 261, you can also see it's also considering the space. If I hover on 10 something, it also considering a space. So what happens is, it's not necessary that one particular word is one token. It can be sometimes even multiple word, 2 or 3 words together can be one token. That's the reason token count is low, and there is a huge concept behind this. Why is it like that? It's very, I cannot explain that in a very short way. You won't even understand if I do it, but let me know if you guys want a video. I'll do a deep dive, at least like a 15 minutes or 20 minutes video on this entire thing. Okay, now coming back again, now you got the context, right? 31 token, combining all this stuff, system prompt, user prompt, and all those stuff. So for us, the allowed window is 1 million. So at a moment, okay, in one single conversation, the agent can remember only 1 million context. And if you're exceeding that, then it cannot remember, it will throw an error. Okay, so what we have to do? We have to handle that case. We cannot tell the user, hey, you ran out of the limit, please start a new conversation. That's the one way. Okay, but the problem with that is they will lose all the context data, because when you start fresh, the agent or the LLM will not have any idea about what you conversed. Let's say you're having a conversation about your exams, some concept, okay, some physics concept or science concept. Okay, so you ran out of 1 million context because you were using it for hours. Okay, so many text and all those stuff. So now if you open a new session because you ran out of 1 million window, you have to re-explain that everything, and then if you do that, okay, you will be like, okay, I'm open to do that. You're generous, you're open to do that also, re-explain everything, but the response you get will be very different and very vague, because in that 1 million window in the previous session, you kept not repeating the way you had conversation, train the AI also to respond to you in a certain way. And once you ran out of that 1 million context, and when you start a new session, that training context is also lost. Okay, so the response you get will be really vague and it might piss you off. That's the reason you see so many people are saying, it doesn't respond well, the response changes, the way behavior changes. So these are all very humanly way of expressing things, but as a developers we have to understand why that happens. What is the use, what is the actual reason behind it? This is one of the reason. Okay, I'm not saying this is the only reason, but one of the reason. Okay, so how do we handle this case? Okay, if we don't want to have that, so let's open our board. So very simple, guys. So where is it? Yes, here. So this is what we're gonna do as we planned in the first video. Okay, so if you're running out, if you're, this is your context window, that is 1 million context window. Okay, this is a 1 million context window, and let's say, and we'll keep this as equals to, equals to 100%. So this is your context window. Okay, now let's say you are here. Okay, you are here, you have used up until here, so you are having conversation day and night with the agent, and then you have used until here. Let's call this as 90%. So you've used until 90% of the context, and now if you move ahead it will work. It's not like it won't work, but once you finish 10,000, the remaining 10%, you might have to open a new session, which we don't want to. We want the user to continue using this, so we need a magical way to keep extending this regardless of how many times the user would use this. So for the user it should feel seamless. They should feel like, okay, it's just I'm just using the same session, there's no difference in the response behavior. Also the way it's responding also is no different, and it also has context. That's what they should feel, right? They just have to expand, we just have to keep expanding it. But how can we do it? We cannot go there and then manually increase this number. That's not possible at all. Just remove it. That's not possible at all. So what we will be doing is, so first thing we will do is, oh, array. Okay, here. The first thing we will do is we would keep checking the current usage. Okay, we'll keep checking the current usage. So how can you do this? So in DeepSeek, this is your API response. So in DeepSeek, this is your API response. Okay, so this might differ in multiple different LLM model, but the concept is same. Okay, so in DeepSeek, you have something called, I cannot zoom in here. Hold on. Yeah, you have something called prompt token. Okay, prompt token is 24. Okay, for this entire thing, assistant and all the stuff. Okay, so we're going to use this. So what we're going to do is we're going to check how many tokens I have used from the max to current usage uh, subtracted by the max window or something like that. So our max window is 1 million, and we subtract that with the current usage. Okay, and then maybe you can multiply by 100 to get the what do you say, the percentage also. So once you reach 90%, right, in that, let's just not worry about all the calculation here. Let's say it is equal to 90%. Okay, in that case what we're going to do is we are going to call a service. Okay, we'll call a service. What service is this? So let's just duplicate this. So we're going to take this conversation, whatever the conversation is inside. Okay, and then we're going to make another API call. So we're going to make another API call to DeepSeek again from a different session. Okay, internally I'm going to say DS LLM internally, and then we're going to ask it to summarize this. Okay, so we're going to say, hey, can you summarize this conversation and make sure to preserve the tone. Okay, preserve the tone and response structure and also the system prompt. System prompt is not necessary, but it's good to have here. So what we're trying to do here is, you can ask me, why do we have to do this? Why do we need another LLM call to do this? Because you cannot magically via logic write a summary of the conversation. I'll explain you why we need this. Okay, so now let's say DeepSeek LLM or any LLM in this case, whatever LLM you're using, would give you a response. It's going to say like, hey, blah, 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 blah. Okay, it's going to give you this response. Okay, it's going to give you this response. Now, what we're going to do this is, internally, we are going to create another session, a new session. Okay, user will not know this. For user, we'll just show compacting conversation, like you see in Cloud Code and all those stuff, even in Cursor and all. We'll just show, hey, we are compacting a conversation, please hold on. In the background, this is what we're going to do. So we're going to say, take this particular response from it. Okay, and the system prompt will be similar. We can also ask it to like give us a JSON response. Okay, and ask this to give us JSON response with system prompt if the user has changed it in between or something, and then summary. Summary. So this can be hey blah blah blah, this can be hey system prompt or something like that. So you will get JSON response. This is a quite common pattern when you're working with LLMs. You can ask it to respond in JSON format, it will respond in JSON format. Okay, so you can take this, you can ask me like, this is already in JSON format, like what do you mean JSON format? I'm talking about this. So it's saying, hey, I'm sorry, I don't know your name yet, right? This is a text, okay? And you can actually ask it to respond in JSON. Then this won't be a text, this will be a JSON, okay? That's what I'm talking about. So now what we can do is we can take the system prompt, okay? We can attach the system prompt to a new context, and we can take this summary, okay? We take this summary and then make this summary as the first user context, okay? Meaning when we create a new session, we'll send one API call immediately. So system prompt will be that hey system prompt, and then manually we'll attach user conversation as summary. Okay, so we're gonna say, hey, this is the summary from previous conversation, blah 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 blah, and attach it. Okay, and then agent will respond with something saying that okay, got it, or something like that, and we don't have to show that to users, say the agent responding, and we just let them continue again. So now we have a fresh set of context with previous summary also preserved. Okay, so this will ensure that the user can just start continuing the conversation in the same context without losing the context. User can start continuing the same session without ever losing the context. And if you ask me, is this one of the best solution we have? I'm gonna say no. Okay, this is a good solution, not a best solution. And what is the best solution? We'll talk about that in the next part. In this part, we'll implement this, okay, because this is a foundation. The next part comes on top of this foundation, because without this, we cannot implement that. Okay, so let's implement this. I hope you guys got the plan. If you didn't get the plan, let me know. Okay, and then since we have the good plan ready, okay, so see, this is how you actually work with cursor also. So now we got the plan ready. Right, now I'm going to prompt cursor to implement this, and you can also watch me how I prompt also. And if you're someone who's struggling with agentic coding, please learn from this, and if you have someone who has better workflow than me, please comment and let me know so I can learn from that also. Okay, so I'm going to open up the chat. What is this? I'm going to close this. Cool, I'm using Composer for now, that's more than enough. Okay, alright, so here's the entire prompt that I've written. Okay, so I'm gonna explain this prompt to you because it's pretty big, not pretty big also, but it's just a bit lengthier, and then it'll make better sense once I explain this to you guys. So first thing is we are telling the cursor that hey, we're building the next layer on top of an existing setup. So it knows that we have something existing, and previously we implemented a persistence layer using SQLite for LLM conversation, blah blah blah. So now it has a context. So even though the reason why I'm doing this is I'm starting a fresh conversation with a LLM, right, in cursor. This cursor doesn't have any idea about my code base right now. It has indexed all the code, but it has no idea about the feature and stuff. So this will give it some idea. Okay, now it will go to my SQLite file. It will understand the database schemas. It will understand the table structure better and all those stuff. Okay, now I'm saying, so this is the plan. We are going to, and also I'm on the plan mode. Okay, I'm not on the agent mode. I'm on the plan mode so that it will plan better. So it will say we're going to use usage.prompt tokens from LLM API response LLM API response from from here. So which is this line. So why did I add this line over here? The reason is when I tell it that hey, you have a LLM API response, though our code base is small, it will try to read all the files. Okay, it will try to read all the files, trying to find a LLM API. It doesn't know that we have a file called LLM and all those stuff. Okay, it will try to find all the files. Okay, so to save that effort, okay, that effort means a lot of token spending again. To save this token and speed up the process, I'm actually saying that hey, this is the line you get the response from. So now cursor will automatically know that this is the line I have to check. It doesn't have to go and search through all the files. This way you'll save a lot of time and a lot of tokens. And then I'm also saying that I'll be attaching the API response as well in the bottom just for your reference. Since we're not typing it, right, it's any. So it will just hallucinate if it's any. So it will think like okay, usage token and all those stuff. So I'm gonna attach the LLM response for you. And then I'm saying we'll use this, and we're using DeepSeek V4 Flash LLM, which has minimum context window of 1 million. So you might have to compare the usage.prompt tokens. So we'll attach the LLM response structure so that it will understand what is usage.prompt tokens with the max window. Max window is again 1 million, and get the usage percentage. So once we hit 90% or closer to 90%, we will start compacting automatically. So I'm giving it clarity that when we'll be compacting, and then we'll say but we will do this auto compaction when the request starts. We'll always check if we are over the threshold or under. The safe spot for start compaction is 85% and emergency is 90%. So what we're saying is every time we send a request to the LLM, we start checking this particular usage check, and if we are 80% equal to 80%, 85 or above, we'll start the compaction. But in some case, what happens is, let's say you are right now at 80%, which is okay. You will do a big conversation. It will bump to 91 or 87 or 88 percentage, And the next time when you have a conversation, if you only keep it to 90, it's 88. Now it's right now it's 88, but your threshold is 90. It will say like, hey, it's still 88, let's just go ahead. But then you are having a big conversation which will far beyond extend the 100% or 1 million context, because you're already very close. So in that case, what happens is you will only get half a context. The reason is, if you check models.dev, the output limit is 384,000 tokens, meaning that your output can only contain maximum 384,000 tokens, not more than that. So that will be a problem. That's the reason what we say is, every time you start a conversation, check if you're closer to 85 or 85%. If it is, start compacting. But if you're above 85, closer to 90 or above 90, then you definitely have to compact. But you can also ditch all this and make it 85. That also works. This is just like a very safe spot kind of thing. Okay, because sometimes when you're around, I don't know, 84 or something like that, it's totally fine, you can do it. The flow to compact is, so now we're explaining how to compact. Okay, we are going to get the conversation from the DB, and we'll send a fresh request to the same LLM in a different session to get the summary and response in the JSON format. We'll get back the system prompt and the summary, such as, and we'll get back system prompt and summary in that JSON response, such as, and use this as the user prompt to get the summary. See, you might have to read your prompt again so that you can refine it more. So we're saying that, hey, can you summarize the conversation, blah blah blah. And once we get the summary back, we'll create a fresh combo with the LLM. But in the DB, we'll replace the entire message with the above response, meaning that whatever the database we have here, right? So whatever the conversation we have, what the hell? Where did everything go? Huh? What? Huh? Oh man, whatever, fine. So what I was saying is, whatever the messages we had, we'll just clear everything and replace the fresh new conversation now. This is also bad. I'll tell you why it's bad. Okay, later, not now. So we'll first implement the foundation, and then message above response in the following structure, all the stuff, blah blah blah. Then we send another request. This will make sure LLM now has enough context. Then we get response. So basically the same thing I'm explaining to it. Okay. And there was one more thing I wanted to add here. I just forgot. I just remembered I wanted to add something. I just forgot now. Let's see if AI can catch that. Okay, now there's one more thing we can add here to improve everything and have it in my blog. I don't have it copy pasted anywhere, so I have to like manually go and get it. So if you guys want to have like, a readers or something like that, please subscribe to my blog also. I'll link it below. I keep writing really good content, this is not like textbook kind of content. These are some of my own experiences that I experience, and I find it fascinating, and I write it. Okay, so if you go to my first blog, how to make AI coding workflow, and scroll down, you have some prompt here. So you find a tweet like this. Okay, this is a tweet from an Anthropic developer here. So we're gonna copy this prompt that from him. I use this prompt in my day-to-day workflow, even in my work also. So I'm gonna copy this and put it at the end. So what this will do is, it says you can interview me in detail using the ask user question tool. This is especially for Cloud Code. Okay, the Cloud Code software that you guys use, this is especially for that. But this applies to all the agent also. They can also understand this about literally anything, technical implementation, API design, UI, UX, trade-off, and all this stuff. At this moment, you can keep it, it's okay. Trade-offs and so on. Make sure the questions are not obvious, and be very in-depth, and continue interviewing me until it is complete. So now what it's saying is that, hey, do not just accept whatever I've given to you and start planning. How about you just interview me and grind me in all angles so that we can find some of the things. Okay, and I'm gonna start the planning now. So I'm gonna send the request. Now let's see what happens. So it's thinking a lot. It's like, oh, user is saying that, user is saying this. Now there we go, we got a question. Now it says, when deciding whether to compact at the start of the request, which token count should be drive, 85% or 90% check. Note, only exists after a prior API call. It won't exist in the first method. Okay, so it's saying that okay, we forgot to copy paste our API response. Fine. So what it's saying is that, do you wanna have a single number, 85% or 90, and then saying that this usage.prompt token will only exist after a previous API call. So now it won't exist during the next message that the user is doing. So should we persist that and then check it? That's the case, right? So we're gonna say persist usage token from the previous turn in SQLite and compare against 1 million before sending it. So we're gonna use that. The reason why you have to do it in SQLite only is because if you close your laptop and if you're not storing it somewhere which can persist your laptop closing, then you will lose it and then you'll run into some edge cases. So because if you just store it in a variable or an array or something like that, then you lose it. So better to store it in a database only. So next time when you come back and also do it, it will pick up the compaction while detecting it. Oh, this is a good question as well. It says that when you're compacting a conversation, you're sending a separate request to get the summary, right? And how do you want to say, how do you want to structure that? Do you want to structure that as a complete history or just like one single message? I think it's better to like complete it as an history so that while summarizing you can understand the conversation and the tone of the conversation also, so that we can preserve that. So we're gonna say dedicated compact system prompt plus user message with conversation dump. I need a dedicated system prompt, but preserve the conversation terms as is. So what I'm saying is use a dedicated system prompt, meaning that one that we wrote, right? You are summarizing, you want to summarize, preserve all these stuff, blah 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 and everything, but preserve the conversation terms. Conversation term in the sense user agent, user agent, user agent terms. Okay. And how should we enforce and pass the JSON response, etc. Strict JSON, pass with retry on failure, extended system prompt. Oh, no, strict JSON. Okay, it's asking like, do we want to separate everything, like the tone and all this stuff? We don't want that, right? We just want prompt and summary. Continue. Action stored prompt tokens should drop sharply. If the next round resume request still reads 85%, miscount or huge user message or summarize failure, how should we compact on the request? Good question. So what it's asking is, now let's say you reach 91%. So we compacted. We did the summary and we rewrote the DB. Now what if this number is still not changed? So with a new session also gets conflict and then we keep in this compaction loop, right? It's asking that. So what it says, every resume request if stored, we can compact again if you just compacted. Oh wait, that's not the question. Every successful compaction stored from token should drop sharply. The next resumed request still reads 85% miscount or huge user message or summarize failure should be compact again on every request. I think so, yes. If stored prompt is above 85% then compact again even if we just compacted. I'm gonna just add some conversation here. So what happens, this is one of the edge cases I was talking about. So what it's saying is, let's say we just compacted and we're sending a huge ass request, sorry, or forget that. We have 84% compaction rate right now, sorry, 84% user usage rate, and we send a huge request which will obviously run over 100% limit. So we need a way to figure out also that also. So if I'm at 84% and I'm sending a huge request, I should be able to figure out the approximate tokens and then realize, okay, I might have to like do this compaction immediately now. Though it's 84%, depending on the request size, we have to take a decision. And that is one of the edge cases talking about. Not the only one of the edge cases. We have to like tokenize the entire conversation and then figure out the number. We'll do that. So that's the reason I'm telling it. You're assuming that already. We're not handling that in this case. It's out of scope, so ignore it. I gave away one of the edge cases for you guys. Alright, so we'll about the request because we don't want to handle the error case right now because it's a bit of a edge case and we need to rewire some of the thinking here. And since this particular setup will change, okay, and since that will change, I don't want to just refactor the error thing again. So we'll only think about the happy case right now. So we're gonna continue. This video is getting lengthier, guys. I might have to either trim it or maybe continue it in the next session. There we go. And as I was saying, the entire goal for me here is to understand the system, understand the decision making behind it. And what do I mean by decision making is that whatever I'm talking to you spontaneously. Okay, I'm not prepared anything. I don't have any system design plan for this because I have no idea about the system. I am just on the spot coming up with some ideas. I am referring to online. I am reading blogs. Today, if I'm talking about compaction with you guys, it's because I've made my research on that, I've understood the system, and then I'm trying to implement it. Okay, it's a different experience to read and understand. It's a different experience to code and understand. Okay, I'm doing both because it's important. So I hope you guys also got some idea about this entire stuff what I did. It's really important to follow these guys. It was a bit annoying, I'll be honest with you guys. Okay, the plan is ready, but it's very important to do this. Okay, let's view the plan first. So it says that context compaction layer threshold signal is 1 million only for resume, skip that. And you can say like 1 million, are we hard coding it right now? Yes, we are hard coding it, but tomorrow, then not tomorrow, but in the next video I'll show you how to get that dynamically also. So trigger is when it is 85%, 95% band is for documentation only. Token budget is the two prompt tokens, and fail hard on summarization. Recompact on summary still huge, out of scope. Ticking settings same as normal. Okay, so we get the chat ID and user prompt, load the conversation from the SQLite. Chat ID exists, yes. Prompt token is equal to 85% above, yes. Isolate summarizer call, replace the system prompt user summary, acknowledge call, call the, make another API call and persist that user summary and basically replace that messages, update prompt token from the acknowledgement usage, and then go ahead with the new user request. Okay, and then if it's no, we're gonna come back and then do this again. All right, append turn. Okay, next turn. So we're gonna be doing a migration, we'll be doing the refactoring, we will be doing a new module. I'm more interested in the system prompt. Hey, you can summarize this conversation, make sure to preserve the tone, response structure, and system prompt. Respond with JSON. System prompt surprise. Okay, perfect. Things are looking good. You can read this entire plan like this and verify everything is right. You can say I'm using bun, so I'm also have to make sure it is also running bun, not npm. Um, these are stuff you can verify, and then click on build. All right, guys. Seems like it's done. Now we have a couple of things created here. So the first things I'm going to do is I'm going to open up migration 2. I need to check it. Okay, alter table. We don't have down migrations yet, only up migration. So migration is not a big deal for me right now. So I'm going to just keep it simple. So we are adding a new prompt tokens column. Okay. Coming back to the compact.ts file. So let's read this. So the first thing is the system prompt. So here the threshold is 85%. I'm going to make this as 1%. 10%. The reason is to test it right now. Okay, 85% is something we'll keep it, but to test it, I'm gonna make it as 10% or maybe 5% also, 0.5. Okay, 5%, 2%. Actually 1%, because you saw right, we only send small messages. It will be like 0.0001%. So we'll keep it 0.01%. Okay, if it 1%, then we'll just compact it. So here's the thing. It says you are a conversation as compaction assistant. Your job is to distill a long chat into compact form that preserves needed continuity for conversation faithfully. The output only valid JSON with exactly two acceptable two strings field. System prompt and summary do not wrap the JSON in markdown fences or add any other text. What does this mean is that sometimes the LLM can add markdown syntax like this. Okay, JSON, and then it's gonna do like this. This is not needed. That's what you were saying there. Okay, and then do not system prompt durable persona constraint. Like basically we are just giving it some more details, and then summarizing instruction. What is the instruction to summarize? You can. I'm just saying this is my dumb prompt, like preserve the tool, response structure, and all those stuff. But this is more detailed. Like thank you, Composer. Composer is the LLM that I used right now. Okay, to work. Anyway, so we have the compaction result. Should compact. So we're checking if the prompt token is null, then return. If it is prompt token is divided by the max token is greater or equal to the compaction threshold, because once you divide the prompt token by the max token, that's 1 million, you get a decimal number. We're just checking if it is equal to or above the threshold, and then we have the pass compaction result, and this is what we're going to do. So we get the result API call, API response from the LLM call, and then if it is an error, we just throw an error, or if it is an object, or if it is null, or we're just doing some random hash checks here. So again, we're throwing an error if it is not something that we wanted. Okay, it's like it's null or some other random hallucinated structure or something. We're gonna throw an error. Okay, something went wrong. Okay, and then we have summarize conversation. That's the function we need. So we have the payload deepseek v4 system prompt, and then the messages, every messages that the user has, user the assistant have had, and that at last one user message saying that he summarized this. Okay, thinking is enabled, effort is high, stream is false. I think we can also add JSON stuff also here, but okay, let's just try this out. And then we send the API call, and then we get the API call, and then we have compact. Okay, so compact is a top level function. So whatever the response we get, we parse the compact result. Okay, this is what we do. We parse it, and once we get the JSON details of parse it, we return it. So now we have compact conversation. The first thing we do is we call this summarize conversation API. Okay, we get the system prompt and the summary. Why? Because this parse compact result enabled us to export it. Okay, then we add that in the object, then it is we stringify it. Okay, and then we do db run begin. Db run begin is a transaction, so it's like you either complete it or you roll back. This is important because if in case, let's say, while updating the conversation in our db something failed and then we are left with inconsistent data, then it becomes a huge problem. Okay, because then you won't be able to compact also, then you won't be able to resume the conversation also, so you'll be stuck in between. So what we're doing is either complete the database update or just go back, roll back if something went wrong. Okay, that's why we're using transactions here. So this is called database transactions, like a usual concept in relational databases. So we do like update conversation set data where id equals conversation id here, and then we are sending the payload. The payload is this. Okay, and then we get the acknowledge. So llm continue. So what is llm continue? So we go back here to llm.ts file. LLM continue is a new, seems like apparently a new function it added. It's calling resolve messages. So what is resolve messages? So resolve messages is getting history of the messages and the current prompt, and it's adding a fallback system prompt and a rest history. And if in case history has system prompt, it will add it, or else it will use the fallback. And then it has, you can actually see it's also slicing out that system prompt from the rest. Okay, rest is all the rest of the conversation, and then it's sending the message. It's a good code, to be honest. So that's what we're doing. So and then we have chat completion, same API call over here. So it's doing resolve messages. Basically what it's doing is it's building the message format. Okay, it's building the system prompt, it's adding all the rest of the conversation in resolve message function, and then it's sending that system and the messages for us so that we can just send out the API call. That's what we're doing. To be honest, this was not needed. We could have used this directly, but anyway, sure. Coming back to the compact.ts. Okay, so we'll test it out, we'll refactor this later. So acknowledge data we have, acknowledge message. So if the acknowledge message.content is not there, then we say acknowledge return empty response. If it is acknowledged, then we're going to store the acknowledge message. Again, develop the payload, update the conversation set. We can also make a function for this, also reusable function, so that it will be called properly instead of rewriting the insert query all the time. Update query all the time. And then we commit. Okay, if in case we get an error, we roll back. Okay, database transaction. That's what we're doing. In the index.ts file, load conversation, we're doing it, and show system message. Okay, main file, what did we update here? Chat ID, yes, should compact. Okay, so we're checking if we're supposed to compact. If we're supposed to compact, then we go to compact conversation and then do all the stuff. Okay, the same stuff. That's what we're doing in index.ts file. All in all, pretty good code, I guess. I can also share this in your my GitHub, guys. You can check it out once. Okay, if you're not able to like follow up in the code, once you have a look at the code, you'll understand how straightforward it is. And rest of all this stuff are similar. Okay, and let's run this now. Burn okay, everything is installed. Burn run index. I'll probably use this only. Use this ID, space ID. Close this, bring this up, go. Okay, so we said, hey, your name is Pavan, and it gave me some details and all those stuff. And if I come back and check out, if I refresh, 67 tokens. And I don't think 67 is, let's see what it is divided by 1 million, man. 67 divided by 1 million. Holy. You know what I'm gonna do? I'm gonna decrease the context limit even more. So here, instead of 1%, because going from here to 0.01 is too big. Okay, so I'm gonna do this to 167. 167 is too much, I guess. Let's see. Okay, so we'll save it. We'll restart the server. Okay, we'll do the same this one again, but this time I'm gonna change my prompt. So I'm gonna change my prompt to index.ts. What was the prompt? Hey, what is your name, right? Where is the user prompt? Oh, we can send another user prompt in the terminal itself now. They updated it. So the same ID, I'm gonna send a second prompt. I'm gonna go here. I'm gonna say summarize this article from Pavan for me in 10 words or less. Let's see. Okay, got it. So we need to interpret, summarize. Okay. So here's a quick summary of our conversation so far. You introduced. Oh man, you asked me to confirm your name. I currently answered it. Now you're asked to summarize, which I just did. Let me know if I go deeper or something. Go. We got another problem. We got another problem. This was something I didn't expect, to be honest. It's look at the reasoning content. It says we need to interpret summarize in context. The user just asked what is my name, and I answered Pavan. Now they say summarize. Likely they want me to summarize the conversation so far. The conversation user introduced themselves, what is my name? Oh, okay, it's misinterpreting this because of the word summarize. I'll change the prompt now. Before that, I'm going to go to SQLite. I'll check the usage. It's for 122 and our compaction is for 167. I'm gonna, what is that, this one 82, right? I'm gonna move this to 100. I guess it should work. Okay, so now coming back, instead of summarize, I'm gonna say explain. Explain this article in 10 words. Let's see what does it say. Oh, got it, got it. Let me explain what happened in a conversation step by step. You introduced yourself, you said my name, and then you tested my memory. You asked, what is my name? Because you told me earlier, answer correctly. You asked me for summary, I gave you a brief chat so far. Now you're asking me, so here am I explaining each step in details. I remember, okay, I think maybe passing it from my terminal is not good, I guess. Let me just hard code it. Okay, I'm gonna just hard code it in. Before that, let me check the DB. How much? Oh, 164. It should compact now. Let's see. Index.ts file. Hard code it here. Cool. Now I'm gonna clear everything. Send it again. It might take a while, I guess. I should have console logged it, man. Oh, there we go. Harness SQLite journal. What? Okay. Oh, there we go. We got it. So here's your article in this. Oh, there we go. I think it was a problem with the what do you say, the terminal itself, because now it's able to issue your article 10 words or less. Tips to optimize AI coding effectively. Got it. See, it's working. Now it's coming back to harness 279. Did this summarize it? I don't think it's summarized, man. Yeah, I don't think it's summarized actually. Um, mm, 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 mm. Conversation compact.ts. I'm gonna add a compact.ts here. I'm gonna say when you're compacting conversation, console log. Let's see. It should compact now because we're way over the limit. Oh, it's compacting. Oh, it's working, guys. It's working. Uh, my this one might be low. Like what do you say? This thing is low. Not low. Like the my prompt is a bit straightforward, so it's just responding that prompt, which is actual behavior because the agent didn't even show anything related to the compact. It didn't even leak that it acknowledged it. It just said, oh, this is what your query is. This is my response. And in any way it didn't leak that it actually made some compaction behind the scenes. And for us in the database, when I open this, system prompt is, there we go, it has changed gradually. You can see it, right? Our system prompt was not like this. It was like, you are a helpful assistant, your name is Cairo. But now you can see the system prompt has changed, and the user role has also changed. You can see the summarized response here. And assistance is that correct, Pawan. I'm glad I could help with summary, blah blah blah, acknowledgement. And then I said explain this article for Pawan. Oops. Okay, I said explain this article, etc., etc. And then it said in 10 words or less, tips for improving a coding workflow effectively. So it's working, right? And everything what you saw is one shot, right? I didn't even do multiple iteration with the cursor right now. All we did was we spent some time planning, we spent some time implementing the same plan in cursor, and all we did was just build it, and one shot the feature was implemented perfectly. Okay, and sure, the code might be bad, and to be honest, the code is not bad at all. It's pretty good. It's well organized. Okay, So that is it for today, guys. I hope you guys were able to understand everything that we did here. Okay, it was a pretty multi-step flow, pretty intense one, I would say. We missed a lot of stuff, not on not on purpose. It was on purpose, not by mistake, because it's a pretty big concept. This entire thing is may take like few more videos to complete this, and yeah, we'll get back to this later on. All right, but you guys understood the gist, right? It's all about functions. It's just about few more API calls. So all we did was that we made multiple API calls. We used the same database to store data, manipulate data, and then store it again. That's all we did, and we got the context compaction. And I'll reset this 85. Okay. Alright guys, with that said, in the next video we'll tighten this more because there's a lot of edge cases we haven't handled, and there is actually better way to do this. I'll tell you why is that a better way and why did we do that first, why did we go this way. Alright, thank you so much. I'll meet you in the next one.